High-performance computing is a major theme occurring in our world today. Can you explain this area of interest?
Yeah, so high-performance computing is really, for us, it's the companies that help enable the acceleration of Moore's law. And so what do we mean by Moore's law? So if you go back to the 70s when they first invested, transistors or semiconductors, the first computer chip had roughly 2,000 transistors on it. And every couple of years they managed to double that to 4,000, to 8,000, to 16,000. And also lower the price over time. And so what that means is computers get faster and they get cheaper. Last year, NVIDIA developed the A100. It has 54 billion transistors on it. So that's how far we've come in the last 50 years. And this year, they've got the Hopper H100, which has got 84 billion transistors on it. So that just gives you an extension that they've done over the last couple of years. And so when we think about high-performance computing, we're thinking about the companies that are really at the leading edge of this. So who are the guys who are making that acceleration happen? And if they can make computers faster, then that makes their products very valuable. Why? Because faster computers is the way to make your business better. Amazon, Google, and Facebook, and Apple, and Microsoft have proved it for years. And every company and the other company in the world is trying to get there. And so really the people who control this technology to make computers faster, we categorize them as high-performance computing. And they really are the fuel that's going to drive all technological development into the future. And that's what we're looking at when we look at high-performance computing.
And you talk about the fourth era of high-performance computing. What is that?
Yeah, so from our point of view, if you look at semiconductors over that long period of time, so that same period of time, as they got faster and cheaper, we could get computers to do more things. And so there's four really defined eras of computing. So right back there in the 70s, we're building them just to do a mainframe, so like NASA, get the man to the moon, those big computers that took up a whole room. And then we moved into the personal computer era, so everyone got a personal computer. So instead, the same computers, the same chips got faster and cheaper and enabled you to have the personal computing boom, which really drove things like Microsoft and Apple. We then had the mobility boom, which is we moved computers onto mobiles and watches and elsewhere. And that mobility boom has really driven us to roughly $500 billion per annum in semiconductor demand, purely because they got cheaper and faster so they could do more things. This next area we're moving into is the AI area. So now the semiconductors are going to get cheaper again and faster again. And so what that means is you're going to connect everything to the internet. 5G is going to enable you to connect, obviously not just your computer, your mobile and your watch, but your washing machine, your fridge, your TV, the car park you park in, the sensors on your car, etc. will all be connected to the internet. All that data will go to the cloud, and in the cloud it'll be processed really, really quickly by software robots to create artificial intelligence outcomes. And so this is really the next big era of computing. And to make it work, they're just going to have to throw lots of silicon at it. They're going to have to throw lots of semiconductor demand. And so we think that's going to drive semiconductor market from $500 billion to $1 trillion by 2030. So it's going to double in the next 10 years. And so from that point of view, that makes it a great structural growth opportunity to the companies that can provide that silicon.